Hello everyone, welcome back to CMSC 201. This is lecture 3 technically, but it's really lecture 2 that we're actually doing coding. We're going to be talking about variables today and conditionals. So that's the idea. Here's some announcements. I've posted lecture notes under the Blackboard course description, or no, course contents. I'm not exactly following them anymore. I think live coding is better. On the other hand, if you want a resource, they are basically the same material, right? Just a different way of presenting. Okay, so that's that. What else do I have to say? So yeah, start going to your discussions, on Discord. This week, attendance was just testing. Next week, attendance will count for 2 points. The lab will count for 8 points, which, if you notice, makes 10 total. Yeah, the other things are that, remember I've set lab due dates are Mondays now. Homework due dates, except homework 0, perhaps, right? I forget exactly when I think I made homework 0 due this Friday, but I hope most of you have already submitted homework 0. Discussions, so you signed up for a discussion. That's the time. Yeah, my car is still snowed in. I haven't even left. Well, I left the house yesterday, but I took the other car. So, yeah, due dates for homework are Fridays. I know it might be a little confusing, and I used to like to keep all the due dates on Fridays. I'm gonna stick with what I say because my decision is my decision. I changed that. This is definitely a lecture. So let's see here. What was I going to say? Right. So there was a typo, I think, on Lab 0, or it wasn't really a typo. It was just from older semesters that said that the labs are going to be due on Fridays. But I'd also adjusted the due dates to Mondays anyway, and for Lab 1, the due date was adjusted to Mondays. So the labs are due on Mondays now. This is a course-wide change that I'm just making, so occasionally you may see some reference to Fridays, but I have good reason for it, right? It's not random. I'm trying to get people to do the lab first, right? So what happened a lot last semester, as I say, people waited until Friday, then ran out of time, right? And the point is that labs should be done the day they are assigned. But you have a huge amount of time to get them in, but the point is they should really be done the day they are assigned. I've told the TAs to be a little bit more, shall we say, helpful or pushy or hintful or whatever you want to say. Some of those were words, some of those were garbage. Basically, my goal here is to make labs closer to what they really should be and what they were back when we were doing them in person. Labs are basically tutoring sessions, okay? So your TA is going to do a little discussion with you beforehand, and then they're going to give you the assignment, and then you should work on the assignment. You shouldn't just go away. You should actually work on the assignment. Back when we were in person, you know, when we were in person, they had to be done during that hour, right? And as I said before, except for the first, like, 1 or 2 labs, right? One which I created new, and the other one I might have modified. You know, a few labs which I might have modified slightly. They are the same labs, right? The same labs that people finished in 30 minutes. So the point of what I'm getting at here is that I know last semester there was a huge amount of confusion about what the purpose of the labs were, and in the end people ended up not really doing the labs until the homework due date, and then they would run out of time for both, and then they would be like, well, I didn't submit the lab, can I have an extension? And I was just like, come on, like, try to get the lab done, because it's actually a way to help you with the homework. And I know I said this on the first day of class, but I'm just repeating myself, because guess what, sometimes that's what you gotta do. Okay, yeah, so there's lecture notes under the Blackboard contents. We're not following them exactly, but that doesn't mean they're irrelevant, right? They are the exact same material. I'm just not actively like going slide by slide anymore. Live coding is probably better. That's why I do it. If you want a resource, they're basically the same. I got the GitHub working like 5 minutes ago, so that's another thing. I think the GitHub should be up and running now. Right? So I didn't have anything posted before, but I just posted the previous lecture's code to the GitHub. So okay, and I think that's basically it. Homework 1 is coming out on Friday, and it's basically just going to be print and input. So my goal this semester, this course is very fast. And so I was trying, I rescheduled the course a little bit in the beginning section to I'm trying to slow it down about 10%. So just so that we can, the thing is that we have to get through basically all the material by like 2/3 through the course. And the reason why we have to get through all the material so early in the class is because then you start doing projects where you use that material. So you have to have everything early. So basically, that's why the course is so accelerated. I'm trying to find ways to kind of make it less intense. Our homework structured like an extended version of the lab. Homeworks are basically, the way that homeworks are going to be structured is generally 5 problems you submit, each as a separate file. So basically it's like 5 times a lab assignment. Some lab assignments are like multiple things, so I'll just put that in quotes so that you know it's basically 5 lab assignments just kind of smushed together. Yep. So it's basically that. I can show some examples. Yeah, basically, that's more or less correct. Okay, so, I think that's it for announcements, and I've spent 8 minutes on this, so that's too much time to spend on this. So let's get back to coding. Okay. So from here on out, I'm just going to use PyCharm. I may switch over to GL sometimes and show you things on GL, but generally I'm just going to use PyCharm, and the reason is because it's kind of what I use to code, and I'm pretty lazy, so I'm just going to do that. Wherever you code, it should go basically the same way, obviously. Python is the same, whether or not you're doing it in PyCharm or in something else. So anyway, okay, so let's begin. So let's do a little bit of review. So, so I guess I'm going to teach comments now. So if you use this # or hashtag or whatever you guys call it. That will start a comment, a single line comment. And you've seen me do it before in the previous lecture, but I'm just saying it explicitly so you know what it is. Yeah, so basically a single line comment is something where the interpreter, I guess I should say the Python interpreter, basically ignores the comment lines. So if you want a multi-line comment, are done like this, where you have basically this, the 3 quotation marks here, the 3 double quotes, and PyCharm is nice to you. When you do 3 double quotes, it'll create the other 3 double quotes and you can just hit enter. So this so what it actually is a multi-line string, but actually Python, it's coding standard in Python, and you see that actually it doesn't have a variable name, so basically it's a comment, and Python will interpret it as a string, but then since it's never assigned to anything, it just kind of forgets it. So technically, you can't do anything too horrible inside of here, because Python will actually try to interpret these multi-line comments first. Of course, it interprets them as strings, so really as long as you're not like breaking out of the string somehow, you should be okay. Anyway, okay, so that's how comments work in Python, and I basically use comments to describe how, to describe what I'm doing while I'm coding, and I think it's, so, oh, that's a good question. So, how many, do I need to comment my code? The answer to that is yes. Do I need to comment nearly as much as these lecture files? No. Right, so do you need to comment your code? Yes. Do you need to comment every line? No. Do you need to comment, so we'll get to that when we do more stuff. So let's review. Variables. So we talked about variables last time. Remember that a variable is really it's an abstraction of a memory location in RAM. And so, or maybe even multiple. So a variable is basically an abstraction of a memory location in RAM. We give these variables names so we can refer to them, right? So there's some rules for variable naming. So what are the rules for variable naming? 1 has to start with an underscore or a letter or lowercase. 2, it has to be made up of numbers, letters, underscores. Okay, that's it. So, yep. And I think it should not be, well, okay, so, yeah, it has to start with an underscore or a letter. Numbers, letter, and underscores make it up. So basically, things like how do you create files? How do you create files in projects? So you right-click on your project, you click on New, and then you go to Python file, and then you type in the name of your file. So remember that we also have coding standards for Python. So basically the coding standard is snake case. And snake case is, all snake case means is that variables are lowercase and underscores made up, and lowercase and underscores. The other rules are that they should be, you should have meaningful variable names. And you should spell out words when it makes sense, meaning when it's not way too long. And for abbreviations are okay. So some examples of snake case are this integer, my string, favorite number. No, so camel case is something that's done usually in Java, JavaScript. You see it sometimes in C++, some other languages. Camel case is no underscores. Words spelled out. First word, lowercase, all others, first letter capitalized. So that's camel case, is when you say something like, my integer, this variable, oops. So for homework 1, if you use camel case by mistake, your TA will kind of yell at you and be like, hey, this is Python. Python has the PEP8 standard, use snake case. Which do I like best? Well, I've been doing a lot of Python, so I've been really using snake case a lot. I don't know. I don't really have a favorite. I guess it doesn't really matter to me anymore. I used to hate the underscores, but then my muscle memory improved to, where the underscore key was. Like I wasn't hitting underscore nearly as much. And then I think as soon as my muscle memory improved, then I was basically happy with it. So camel case is acceptable in Python if your project is already in camel case. So basically Python says like whatever is the coding standard for your project. But basically in this class, assume our coding standard is this one, like, snake case. This is the coding standard. I've just gone over it. So, okay. So, all right. So we know how to declare variables, right? We can make. So you can make something called like radius is equal to 4 or 5, I guess, times say pi times, or no, radius is 5, and then say area of circle is equal to pi times radius, and remember, so, okay, let's declare pi. So, basically, it doesn't like that. So, right, so basically here, this is pi r squared. I know that sometimes, there used to be a coding standard in the course that said that you literally could not abbreviate. I really don't care. Like, if you made something a radius and you call it r, as long as it's obvious, it's okay. So, I should say, like, obvious abbreviations are okay. And single letter, I would say avoid single letter variables, except as loop indices. So don't just be like x equals, 31 times radius plus 2 times pi minus, area of circle squared, right? Because, so don't do this. No one will know what the heck this is, right? Right? It's clear that you're calculating something, but no one, like the next person who looks at your code, i.e. your TA or even yourself in a week, right? So, you in a week or your TA won't know what this is, right? So that's why you don't do it. Okay. So, so let's go over the variable types. So what are the 4 in Python? And I should say that they're the basic, I'll call them primitive. Okay? So, the first variable type is, we've been using a lot of them, integers. So for instance, if you declare, my integer equal 5, that's an integer, right? Integers are whole numbers, positive. Well, I think whole numbers are only positive, but basically it's either positive or negative times a whole number, right? Or 0. Oh, that's just my dog running around. Once I get a working webcam again, maybe I'll do dog cam. Okay, so there's another type of variable, float. And so float stands for floating point, which really just means that it's made up. It's the way that the variable's encoded into Python, or not even into Python, into RAM. No, I'm not trying to hit 1 million subscribers. I think I'm pretty far away from that. So yeah, float is equal to floating point. So it basically means there's a decimal in it. And so for instance here, so if you have my float is equal to, say, 1.6789, right? That's a float. But this is also a float, 5.0, right? So if you ever need a float, but it's also an integer, you can just put a 0.0 at the end, and Python will figure that out. Okay? So that's how to declare a float. And then there's also strings. So, and I guess the other thing is, I know last time people mentioned a double, so last time people talked about doubles. In this case, Python doesn't have a double because its float is actually far more precise than the C++ float type. A Python float is not just a C++ float. It's actually more like a double. I think secretly it might be a double. Basically, double just meant that instead of being 4 bytes, it was 8 bytes, I think, right? So a float versus a double size. I think, yeah, the double was 64 bits, and the well, so that's, I described this last time, so you have to be careful with round-off error. So converting from a float to an integer is a pure truncation, which you can basically call rounding down. So for instance, if I print out the int of 5.9, the int of 5.2, the int of 5.001, and finally maybe even the int of 5.0. So, let's see what happens. Let's run this code. I don't think anything else actually does anything, so basically we're just going to get these printings. So you see that 5.9 Yeah, I mean, you can say rounding down, but yeah, truncation is definitely more proper because it takes whatever the integer part is and then just kills off all the decimal part. Yep. So okay. So that's basically all I want to say about floats right now. It's like an integer graph. Not 100% sure what you mean by graph there. So let's talk about the next data structure, data type. Talk about strings. So strings in Python are things like this, where you have string is equal to, and remember you can use this kind of delimiter, meaning that is a single tick, single apostrophe, and then a double tick string equals, you can also use this delimiter, which is the doubling, right? And so the question is there a difference between these types? Well, let's print out the type of a string and the type of double tick string. So remember that type is something that you aren't going to use in this class. It's just something I'm doing to show you that I'm not playing any tricks. So if you notice here, this thing is a string and this thing is a string, right? So they're both equally strings. It can't tell the difference. So I know that in other languages, if you do a single tick, that would be like a character, and if you do this, it's a string. Python doesn't really have characters. It does have length 1 strings. So if you need a character, you can just use length 1 strings, and that's what it does. So for instance, let's say that you want to do something else with a string. So you can add strings. So let's say we want to add 2 strings. So first string is hello, and second string is Python. And I don't know why I mix them. I normally use the single ticks when I guess it's good that I'm mixing them just because. And then we say addition is equal to first string plus second string. And then we print it. And so let's do that. Let's see what happens. So it'll concatenate the 2 strings. So the term here is called string concatenation. And that's where 2 strings, or technically 2 or more strings, are kind of just pushed together into a single new string. Okay. I guess pushed, we could just say put, or added, or whatever. However it makes sense to you to think about it. Okay. So we've covered ints, we've covered floats, we've covered strings to some extent. So the last thing we have to cover is Booleans. So the Boolean type has the keyword bool attached to it, but generally I don't think there's a single instance where you had to use that in the previous class in any of the previous semesters, but whatever. I mean, just so you know, each of them has a way to cast. But what are Boolean types? So there was a guy actually named Bool, and he developed Boolean logic, which is the logic that involves true, false, and then you basically have and, or, and not as like the conjunctions. So basically what you have here is you have 2 keywords. You have true and you have false, right? So those are the 2 keywords. True is basically, the way to think about it is true is basically 1 and false is basically 0 in a computer. That's how they're usually encoded. But as it turns out, there's ways to encode. Well, okay, so basically I should say that if you determine the truth of a thing, basically if it is 0, then it's false, and if it's anything else, it's true, is the way to think about it. But we'll go into that in just a second. So why do we need Booleans? So a lot of the time you use them as what's called flag variables. Are variables that wait until something happens, then you flip them. When you flip them, you detect that in an if statement and do something about it. So basically, for instance, like a lot of examples of flag variables are like server connected, right? Say true. But like if you can detect that the server, it is very discrete, right? It is discrete math, yeah. So, you know, if the server were ever disconnected, you'd set this to false, and then try to fix that, right? Or maybe continue playing is true. In which case you would say, you know, the game is going until this is set to false, then the game is over, right? So for instance, with the Boolean variable type, sentinel values, not sentient values. I'll describe those later. We haven't gotten to that yet. We haven't talked about if statements. We haven't talked about. There's a lot of things we haven't talked about before we get to that term. So basically you actually have. So Python gives you the keywords and, or, and not, and so you can actually you can play some games like that. So for instance, you can build the truth tables. So for instance, if you have A here, where A can be true or false, and then you have B here, where B can either be true, no, I do not want to type, there we go, or false, then the OR truth table looks something like this, right? OR is true when either one of them is true. So basically, if both of them are true, then one of them is true, so it's true. If B is true and A is false, so you read this as B is true and A is false, so then this would be true because it's an OR. And if A is true and B is false, then we get false. And if they're both false, if A is true and B is false, we get true. And if A is false and B is false, then we get false. I kind of jumped ahead in my brain and didn't really think about it. So, okay, so let's test that out. Let's say true or true, true or false, false or true, and false or false. Let's check all these expressions out and see what happens. Cool. So you see here, if one of them is true, then true pops out. And if both of them are false, then false pops out. So that's how OR works. So let's do AND now, right? Let's do AND. So AND, these are just called truth tables, right? These are truth tables. Well, so in Python, when you say like an operator like, right, this is the logical AND operator in C++. The keyword AND is the logical AND in Python, right? So, yeah. And if you're wondering about these tables, you'll see more of them in discrete math, so that's where you actually do stuff. So actually C++ is, and Java, or I don't know if Java has, but C++ is actually, I think in version either C++ 11 or C++ 17, they actually imported these keywords. So and or are actually are keywords in C++ now as well. But whatever. So okay, so let's look at the and truth table. So and works basically the same way as or, but it's not true when either one is true. It's true when both are true, right? So we have to change our truth table here, right? So the only time when A and B are both true is when A is true and B is true, right? So because of that, this one stays true, but these two turn false because when one of them is false, when A is false, or when B is false, the result of an AND expression is false. And of course, I mean, this should make sense to you logically, or no, I shouldn't say logically, intuitively when you think about it, right? When you think about it and you say to yourself, okay, if I say A and B, that means that A is true and B is true. So the only way to have that happen is if both of them are true. So now let's see what happens. Hopefully this will stay true, 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 false, and then the next one should be true, false, false, false. So let's see what happens. There we go. True, false, 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 right? And so those are all the possibilities of, you know, what should I say? Those are all the possibilities for this single expression. Okay. So what else do I want to say? Oh, right, we need to do not. So there's other things other than and, or, and not. Yeah, dog hangs out. So not is different than and or. And the reason why it's different is because not is what's called a unary operator, which basically just means it's an operator that eats a single argument, whereas and or are binary operators, which just means that they eat two arguments, right? So you should probably be able to guess what not does, right? If you say not true, should be false, not false, should be true. So let's print out not true, not false. Hex operators, well, there's not, so hex would mean that like a hex operator would be 16 arguments. So basically what you would need to do is you would have to have basically like some kind of weird notation for that, right? Because like most of the things that you ever deal with are two arguments, like plus, minus, times, divide, integer division, and or not. And I need to talk about integer division. I'll talk about that soon. So that'd be a lot. Some of you may have actually heard of the ternary operator in C++ and some other languages, where basically it's like a collapsified if statement where you have A question mark B colon C, and what it does is it tests A. If true, then B else C, right? So that's how it works. And you see that it's a ternary operator because it eats 3 arguments. It takes 3 arguments. So 1, 2, 3. So that's why it's a ternary operator. Is it the only possible ternary operator? No, but it's like, I guess since it's the only ternary operator in most programming languages, That's why it's called the ternary operator. So you might hear that term in the future. So anyway, so ternary and hex. Okay, the important things here are that not is a unary operator. It just inverts whatever you put in. So if it's not true, then it turns false. If it's not false, it turns true. So let's watch that happen, right? So not true is false, and not false is true. So that's good. So what should we do? I think that's, how much more do I want to say about this stuff right now? I think the answer is not too much. Let me just, the last thing I'll talk about in terms of this, let's just talk about order of operations for and, or, not. So not has a higher precedence than and or. And then and or have equal precedence. And so what do I mean by that? What I mean by that, and so if you wonder, what do I mean by precedence? It means which operation happens first. So for instance, if you've ever seen those things online where it says like, well, I guess the question is like, how do you, well, let's not go into that one. I don't want to say that. What's the better example? So the better example is basically this, 3 plus 2 times 5, right? Without parentheses, this thing is potentially not what you mean, right? And the reason is because maybe what you mean is, or maybe what you mean is, please, 3 plus 2 times 5, or 3 plus 2 times 5. Right, so this is order of operations stuff, right? And so, I mean, you know, back when you did order of operations, you learned that who has the highest precedence, right? Right? I have to make sure I get it right. But actually, PEMDAS is sort of right, right? It's actually, this, right? Because multiplication and division have equal precedence, and addition and subtraction have equal precedence as well. So that's why and or have the same precedence. So really, yeah, so you could even write it, so it could be PEDMSA or PEDMAS, right? So PEDMAS, PEMDAS, PEDMSA, right? They're all equivalent, right? So there's like 4 equivalent statements that are all true. I think that's the other one, right? So point is that that's actually the order of operations in mathematics. And so if we were going to write it, then we would just say negation and an or, right? So that's basically how we would write our current order of operations for logic. And maybe we put parentheses, so PNOW. So, cool, right? And cast the not operator to multiple arguments. No, not really. You can't do like not A, B, C. This does not work. It doesn't like that. You can say not A and not B and not C, right? You can say that, but you can't do. But you see that each time A, say, is true, B is false, and C is true. So let me show you an example where order of operations matters. And let's say that A is true, B is false. And we do not B and A, right? So if, well, let's print this out. So there's two ways that this can be interpreted by us as humans. You can either think that this is not B and A like this, or you can say it's not B and A, right? So let's see here. So not B will turn to true, and so this will be true. Let's change this to or. I think that'll work better. I think when it's and, it's always true regardless. So, okay. So not B is true or A, so that's true. But then not B or A here, true or false. So false or true is true, and then not that is false. So this expression should turn out to be false. This expression should turn out to be true, and then I don't know what this one's going to do, right? Unless we believe the order of operations. So let's run it and see what happens. So we see that this one, right, not B or A, is actually this to Python, not this, right? So this one is the different one. And you see why, because what happens first? Parentheses happens first, but there's no parentheses in this expression. So negation happens next. So there's a negation here, so it says not B, and then it returns not B into there, so it says true, and then true or true is true. So that's how it gets that. And then you see that that thought process is exactly the same thought process as when you believe in the parentheses, and you say that not B happens first, and then it ORs it with A. So these two are the same. This one is not the same. Okay. So this is the order of operations for, I guess you can always say, like, please never attack objects, right? That's the order of operations for logic. Or alternatively, you could say, please never order right? So there's, two equivalent nonsense bits. So, there we are. Okay. I think that's good for now. I don't want to do too much more. We'll do much more on this stuff later. We'll talk more about it when we talk more about conditionals. I think there's one last thing I want to talk about with regard to integers versus floats before we move on to if statements. Right? So I just made these up, so I hope that you remember them forever and it kind of burrows into your brain or something. But yeah, so this is how this is the order of operations for logic. Okay? All right, so let's talk about, so let's take a break from logic for a second and talk about integer division versus floating division. So oh, I like that one. That's cute. So in Python, if you have two integers and you divide them, let's see what happens. So let's say we have 5 divided by 3. And it doesn't like those extra spaces. I was trying to be good, but okay. So, float popped out. That isn't right. Or it could be right, or it could not be right. But sometimes you definitely don't want this to happen. And so if you ever run into the situation where you want to divide two numbers and they're both integers, but you want the result to remain an integer, if you want the result to remain an integer, do this. There we go. So double divide here, this double division symbol, is integer division. And so it's not integer division in the sense that it requires two integers. Actually, it can operate on floats too, but I'm never going to test you on that. So integer division can actually take floats as well. So I think, if I'm not mistaken, because I think I found that out last semester, you can actually do this. But it also spits out a float, and it doesn't behave, it behaves weirdly at times. So I'm not actually going to ever test you on this. This is extra nonsense that you should avoid. But basically, this is actually very useful. This is extremely useful because sometimes you absolutely need an integer, right, as the result of a calculation. You don't care what the remainder is, and we'll talk about how to calculate remainders maybe next class. But if you ever need this, this is what to do. So basically, so here's integer division. And so just remember it does the same kind of thing, so that that the floating point calculation does. It divides and then it rounds down. You can actually cast to an integer, so you can do int of 5 divided by 3, and it should also work. So yes, these two produce the same result. Actually, let's see if they do. So here's an example of something where, so negative 1 divided by 3, so you might think that it's 0, but watch this. The result here was -1. What the heck? And basically the reason is because everything from 0, 1, and 2 divided by 3 is going to be equal to 0. So -1 minus 2 minus 3 divided by 3 is going to be equal to -1. So that's how Python does this. So it's not just... So let's actually see if this produces a different result. Oh, it does. So the result is actually different for negative numbers. Ugh. So this is finicky stuff that I'm not really going to be testing you on. So I'm not going to be testing you on the distinction between like integer division and casting to an int, but this is just like, there's always some oddities in programming languages, and this is just one of those oddities. No, you shouldn't necessarily avoid it. You should just be careful, right? So make sure when you're, if you're dealing with negatives, just understand what it does, right? Don't be afraid of it. Just understand what it does and use it. Use the one you want, right? So you should always test it out. I misspelled weirdly. Okay, there we go. So yeah, that's basically how to do that. Okay. So that's integer division. And I'll talk about mod next time. I don't want to talk about mod this time just because I think I'd like to talk a little bit about conditions. And I think that would be cool. So we'll spend the last, say, 15 minutes, Yeah, it's 4 o'clock to 5:15. So the last 15 minutes, actually 20 minutes really, will be about if statements. Yay. Okay. So far, right, we've learned about printing, inputting, and variables. But you can tell that this can't be all that there is to programming because if you input a variable, there's no way for us right now to make any decisions. So if statements are the basic way that computers / programming languages make decisions, right? So the way to think about an if statement is kind of like this. Let's see, where is my Inkscape? It is here. Okay. So think about if statements like this. Basically, you'll have, gross. Okay. You can say that this is block A code, right? And say that this is block B of code. Okay? And what we have is we have an if statement, if something, and I'll talk about the stuff in Python. And so what we need to do in Python is whenever you do an if statement, you got a tab. And so all the code in here, so let's talk about this. So the A block executes when? Well, when does it execute? Now let's put it here. Right? A block executes when something evaluates to true. Right? And then the B block executes after the if statement. And so what I mean by that is if something is true, then it executes after A block. If something is false, it executes immediately. Right? So an if statement is a way to either, basically, you can either execute the A block of code, or you can jump over the A block of code. And so how does Python know what the A block is? Everything that's tabbed in an additional level is the A block of code. So basically the B block of code is everything that is returned to the regular tab level. So this is, let's just put this at the tab level here, and there we go. So that's the point, is that this is at the first tab level, and the A block gets executed. And if whatever you code after that will be executed regardless, but whatever thing is in the A block of code will only be executed, right? It only happens when something is true. So let's do some examples, right? Let's do some examples, and yeah, so cool. That's enough theory of if statements. Here's some examples of if statements. So let's say we input, tell me a word. Okay. Yes. Functions come later though. So let's say if a word is equal to a robot, we'll print out, you have said robot. I accept this. And then we'll print the program is empty. Right? So basically this print statement is our A block. And this print statement here is our B block. This is before the if statement, so this always runs, right? basically, programming languages evaluate from top to bottom, so this will evaluate, then this blank line will get ignored, then this will evaluate, then this if it's true. So now, thankfully, we get to use the if it's true, then it will do the A block, otherwise it skips it. So let's just talk just for a few seconds about syntax. And so what is syntax? Syntax is the structure, the formal grammar of a language. And what do I mean by that? I mean, it's where words go. It's kind of like saying every sentence in English basically has a subject and a verb, right? So basically the grammar for English is that you would have some kind of subject and then some kind of verb. Now, of course, there's exceptions in English, but basically the way to think about it is in Python, each if statement sentence has a has what? Has an if at the start and a colon at the end. And the other rule is that everything in the middle, everything between if and colon, needs to evaluate to either true or false. And I'll explain how things evaluate to true or false in just a minute. So the other thing to say about this if statement is that you notice here, this is not a single equal. This is a double equals sign. And so the reason for this is that programming languages have a different symbol for test if this thing is equal, which means this, versus oops, there we go, versus assign right, assign this into that, which is done by that is equal to this, right? So basically, so there's two different equal signs in most programming languages. The first equal sign is called assignment, and that's with a single equal sign. The second equal sign is a test. It does a logical check to see if the two things are equal, and that's a double equal sign. And this is true in the vast majority of programming languages, and Python steals it from everywhere else. It's a very consistent thing now in most programming languages. You will be confused when you find a programming language that doesn't implement this fact. So yeah, double equal sign is the test. Single equal sign is an assignment. Now, some languages actually allow you to do the crazy thing of this, but you notice that Python is nicer. PyCharm will yell at you here. It tells you colon expected, but you have the colon, so you're like, well, what's the actual error going on here? The actual error is that it thinks that this might be an assignment statement, and so it's saying you need a colon like here, but then this would also be an error. So really what it's saying is there's some problem in this if statement that I can't really identify. And the problem here is that it needs two equal signs. So let's play the game. Let's click the thing and tell me a word. So let's definitely not robot. Okay, the program is ending goodbye. And now here, robot. You have said robot, I accept this. So there we go. There we go. That's our first example of an if statement. Pretty nice. Pretty good. So let's do another example of an if statement. So let's say you enter two integers. And then we'll enter, say, y is tell me. So I think in this case, it's okay to have x and y as integers that don't really have variable names. So single letter variable names are a little bit dangerous, but here I'm going to justify them just because there's no real meaning to these two variables. They're just like the first input and the second input. So x and y are generally fine. So there's really no difference. So if I say, like, if x is less than y, for instance, then we'll print y is bigger, right? And then we might have another statement. Say we put another if statement here. If x is bigger than y, then x is bigger. And the final if statement that we'll put here is if x is equal to y. So let's run this program and figure out what happens. So tell me a word, ASDF. Okay, tell me an integer 3 and 17, right? Y is bigger. And that's because if x is less than y, then we print y is bigger. Single double quotations, a single quotation. So you can actually use single quotes for a multi-line comment as well. There's no difference between the single tick and the double tick. It's kind of a confusing thing in Python because most programming languages are not so permissive. They're going to yell at you if you like mix your single ticks and double ticks up. But so let's see. Let's make x equal to 9 and y equal to 2. And so now we get x is bigger. And so for the last one, let's enter step 3 and 3. So x is the same as y. So here, what do we see? Right? What do we see? Is that we actually had something a little bit more complicated than my earlier diagram. What we had here was basically we have a B block of code, but then the thing is that the B block has another if statement. So basically what we have is something like this. Oops. We actually have something like this. So if you have two if statements in a row, then what happens in this case is that the first if statement checks. If it's true, it runs the A block. And then because this if statement is tabbed back by 1, right? So this whole thing right here is the B block, right? And then this inside of here is A block inside. So it's like AB block, right? So it executes if that is true. So basically everything else after the first if statement will still execute even if this one isn't true, right? So you have this if statement and then a completely disconnected if statement sitting inside of a different block of code, and then like another one, and another one and another one. So you can chain if statements together like that. So that's why this if statement runs, and then this if statement runs, and then this if statement runs, right? So it's a little dangerous. Do if statements work with strings? Yeah. This one was an example with a string, right? No, these are actually not called nested if statements. These are unnested, which is just if statements, right? I'm just saying that they just operate one after the other. Okay, so let's see here. Let's say this is good. Okay, so I think, what do we say next? What's another good next thing to do with if statements? So say we have an if statement, and we have, say, if a word is equal to salami, and x is bigger than 5, right? Then we can print out some random thing happened to be true, right? Also salami. So does Python have else if? Yes, it does. Yes, it does. So, yep. So, basically here, if a word is equal to salami and x is bigger than 5. So notice here that I'm using an and statement, which means that both of these things have to be true, right? So this gets evaluated into a true and false. Can you tab multiple lines and all? Yeah. Yeah. So, okay, tell me a word. It's going to be salami. Tell me an integer, 17. Tell me another integer, 4. So x is bigger. And then you see here that you can have, basically this is an example. Or right, I think that's the best way to say it. This is an example where we're using two logical expressions together, or we're using a logical operator to chain two conditions together, right? So both of these have to be true. So yeah, so that's, and then let's see, what are some other examples of if statements? Sure, yeah, you can put Booleans in. So for instance, you can say something like, well, the thing about it is it's hard to, why do we have to give a word? We don't necessarily have to give a word, right? But that's just because we had an input statement that made us do it, right? So, yeah. And I'm just stealing that word from the initial if statement. So yeah, Booleans, you can do something like that. So sometimes you'll have statements like if a word is equal to I don't know, happy, then we'll set a variable. So for instance, like, so this is one way to use. If you remember, I was talking about flag variables earlier. So this is an example where you can set a flag, and then later on in your code, you can check if happy was set to true. So it's a way to remember, right? It's a way to remember if something happens. So for instance, here, let's put in happy 2, right? So at the very end, it prints out that happy is true, and then here, word not happy, and that will turn out to be false. So basically this is a good way to, you declare a variable happy, and then a lot of times there's more code here, and then if the word is equal to happy at some point, right, you set it to true, this remembers it for later, and then much more code here, and then finally you get down to here. And so you don't necessarily just have to print it out. Currently, that's all we really do with stuff is just print it out. But a lot of times, happy will then will decide some later if statement or while loop or something. And if it does, then it'll determine how the program works from there. So. Yeah, I mean, you can call, they're kind of like checkpoints. Basically, like once you pass a checkpoint, you check for something, and then if it's true or if it's false, you set it, and then basically for the rest of your program, at least most of the time, your program will have that check set, so then it remembers it. and you can act accordingly. So, yep. All right. I think that's basically it for today. So I'll post this code to the GitHub, so let's do that right now. Git commit. We'll say second lecture, variables, conditions, and commit it, and then we push it. Actually, wait a second. So the last thing I'll say is that next time, right? So what are we going to do next time? We'll do, whoops. Yeah, please don't do that. Next time we'll do, let's see, more about if statements, okay? So, yep. Yep, so the link for the GitHub is, I'll probably post it in the whatchamacallit as well. Let's just make sure everything's working right. Yep, looks like it is. I think I posted in the announcements. I'll probably send it out now that there's actually stuff on it. There was nothing on it, so I didn't really care if you guys had it or not. But now I care because there's something on it. All right. I think that's all for today. Have a good rest of your day, everyone.